In this video, we'll be writing the auto-regressive moving average model. It's a mixed model. For more on this topic on time series, you need to subscribe to this channel. So this model is a mixed model. As you can see, we have the auto-regressive and the moving average at the same time. So the auto-regressive moving average model of order P and order Q model can be written as xt to be equal to, we take the first one P, we can use this as our constant, plus summation of pi I as I running from 1 to P, xt minus I, plus we also have the moving average. This part is the auto-regressive part, while this part is the moving average part of order Q. Here is the auto-regressive part of order P, while this side I'm writing now is the moving average part, I running from 1 to Q. Then we have our theta j e t minus j plus et. The general form can be written. The general form for this can be written. The general form. We can write the general form as xt is equal to, we know of this, pi 1 xt minus 1 plus pi 2 xt minus 2 plus, it continues like that, to pi p xt minus p, plus we have this other part, theta 1 e t minus 1 plus theta 2 e t minus 2, plus it continues that way, plus we come over to this side and write theta q e t minus q plus et. So this is the general form for the model of auto-regressive moving average of order P and Q. Like we see, we combine this. In the general form, it's also combined. So all of these parameters can be defined. All of the parameters we have here can be defined. First, where xt is the time series parameter, theta 1, theta 2, theta 1, theta 2, phi 1, phi 2, they are all parameter coefficients. So phi 1, phi 2 to phi p are parameter coefficients. Also, theta 1, theta 2 to theta q are parameter coefficients. So what are we saying? Phi 1, phi 2 to phi p They are all parameter coefficients for the autoregressive. While theta 1, theta 2 to theta q, they are also parameter coefficients for the moving average part. Then we have the error term. ET is the white noise process or error term or the error term, and 5 is the constant. So this is how we can also compute the ARMA PQ model. For more on this topic, you need to subscribe to this channel. In computation, it's also easier. When we use this format, we can get our autoregressive moving average model of order PQ.